Hello everyone, myself Dr. Praveen Kumar Balguri, Associate Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Welcome to Aircraft Propulsion and Turbo Machinery lecture series. In the last lecture, we have seen different types of gas turbine engines, that is classification of gas turbine engines, and we could learn about different components and working principle of turbojet engine. In this lecture, we will learn about turbofan engine, different components, working principle, and different types of turbofan engines and their advantages and limitations. Before going to turbofan, we'll just recap on turbojet. We have seen the working principle. We have learned that 100% of the thrust in the turbojet engine comes from exhaust to jet air. So total thrust comes from exhaust jet air. That's the reason, and the two are at high kinetic energy. So that's the reason. That is also one reason, or that is a reason for noisy operation of turbojet engine. Right? So in this, now we will discuss. Last lecture we have discussed this, and we will discuss today. Spend time on turbofan. These are the schematic of turbofan engine, which helps us to know the components, important components of turbofan engine. That is inlet section and ducted fan and compressor. So this is the compressor, then combustion chamber, fuel injectors, then turbine, then nozzle, exhaust section, right? So we can see the primary difference between turbojet and turbofan is, except this fan, rest all core engine gas generator consists of compressors and combustion chamber and turbines. This is gas generator, then exhaust section. This is core basic turbojet engine. Only difference in the turbofan engine is a fan, traditionally a fan at the entrance of the engine, front of the engine is placed, right? Physically, physical difference, component-wise difference. And then if you look into thrust production or operation, operating principle is same for this core engine, but overall turbofan engine, actually in case of core engine, total inlet air will be passed through the compressor, then passes through combustion chamber and turbines, right? Total inlet air. But here in this case, turbofan, only part of the inlet air will passes through the core engine, and majority of the inlet air, which is sucked through the fan, will bypass the core engine. In this way. So which means that majority of the air inlet air will not pass through the core engine. Will bypasses the core engine and passes over the core engine. This way, right? And a duct is placed here, and that's why it's called ducted fan. So in this, approximately 80% of thrust is generated by this bypass air only, and then approximate rest of the 20% of the only 20% is generated through exhaust gas. Only 20% thrust is generated through exhaust gas, that is through jet engine, right? So it's not like only 20%. For this 20% only we are using turbojet engine or core engine. No, because primary purpose of core engine is to rotate the fan, right? And that fan, which generates 80% of thrust just by pushing it back and over the engine. right? This way. This way only, like similar to propeller, this way only this fan generates 80% of thrust, right? So the fan here in this case we can see in a way turbojet engine is running or operating to drive the fan only, majorly. So, part of the thrust, that is 20% of the thrust, is generated from the core engine. Rest 80% is by fan. Right. So that's the reason here primary stream only little amount of the gas, little amount of the inlet air only passes through the core inlet engine, and secondary stream bypasses the air stream. Right. This is how a turbofan engine works. And as we have seen that 80% of thrust is generated by fan and only 20% of thrust is generated by core gas turbine engine. That helps in reducing the noise of the jet engine. So when compared to turbojet engine, these engines are quieter because most of the thrust is generated by fan, not by exhaust gases. In case of turbojet, 100% is of the thrust is by exhaust gases, so much noise will be there. Here in this turbofan, only 20%, majority of the thrust by fan, so noise is reduced. So when relatively or comparatively, turbofan engines are quieter, smooth, right? Turbofan engines produce the majority of its thrust, that is by fan in this way, 80%, and which is by using bypass air, and only through core engine only 20% from the exhaust gas. And we'll see the different types of turbofan engines. Here in turbofan engines with reduction gearbox and without reduction gearbox. So if you go back to the picture, yeah. So even though similar to gas turbine engine, here also different stages of compressors as well as different stages of turbine are possible. So like high pressure turbines will drive high pressure compressor, and the low pressure turbine will drive low pressure compressor. Along with the compressor, low pressure turbine shaft is supposed to drive fan also. Here in this case, low pressure turbine shafts will drive the turbine, will drive this inlet fan, ducted fan, right? Even though the RPM of low pressure turbines will be very high, at that high RPMs, if these fans, if you run directly operates at a such a high RPM, efficiency will come down, performance will come down. Because this is similar to propeller blades, right? This fan blade aerodynamics will play a role in this. So for that purpose, most of the, here comes the difference. Two types of engines. Few engines are equipped with reduction gearbox. Here, reduction gearbox, which will reduce the RPM of the shaft, and which will supply required RPM or suitable RPM to the fan, right? So reduction gearbox, function of the reduction gearbox is to reduce high RPM of the low pressure turbine to suitable RPM, reduces, that is, lowers the RPM such a way that fan blade performance is increased, best performance is utilized. So few engines are without reduction gearbox. So that's how we can see two types of turbofan engines with reduction gearbox, without reduction gearbox. So this is one pictorial representation of reduction gearbox, and so we can realize that even though this enhances the life and performance of engine, but increases the weight and increases the complexity of operation. So with the reduction gearbox, increases weight, increases the complexity of the weight, but the reduction gearbox enhances the performance and maintenance as well as operation. Performance of the turbofan engine. Yeah. So another type we can learn is single spool or multi or dual spool. Spool is nothing but similar to gas generator, that is set of compressor turbine connected by shaft, right? So this is one spool. I mean, this is here you can see that high pressure turbine is connected to high pressure compressor connected by a separate shaft, whereas low pressure turbine are connected to low pressure compressor by another concentric that is here in green color. You can see in this picture green color. So this green and purple color are concentric shafts. So this set is called one spool, and this set is called another spool. So here different types of turbofan engines are with respect to set of turbine and compressor blade, that is single spool, multi spool. If it has only one spool, that is one set of turbine connected to one set of compressor by only single shaft, then it is single spool. If it is like this as shown in the picture, it is multi spool or dual spool or multi spool. So these are the another type. First one is by reduction gearbox and second one is by spool. And of course, having a multi spool raises the complexity of the operation and increases the weight, but it increases the performance of the engine. Yeah. So we'll see important term related to turbofan, that is bypass ratio. Bypass ratio is ratio between rate of mass flow of bypass air to the mass rate of air which passes through the core. So here we can see the formula m dot bypass by m dot core, that is bypass ratio. So based on bypass ratio also, we have different types of turbofan engines. Turbofan engine can be low bypass and high bypass. And the definition is again the amount of air that is bypassed around the core of the engine is a bypass ratio. So low bypass ratio turbofans are used for military operations. Low bypass ratio turbofans are military operations. That is, low bypass ratio means only little amount of air passes through and bypasses the engine. Majority of the air passes through core engine. So again, it is almost near jet engine, near turbojet engine, right? Because majority of the here it will be reversed. 10 to 20 approximately percent of air thrust only generated from by using bypass air, and remaining majority of the thrust is generated by core turbojet engine. So this is to get this is for military operations like high speed operations and relatively high altitude operations. So these are low bypass. In this case, this is low bypass. Low bypass is in a way near turbojet engine. So, but it is basically turbofan engine. But when it is low bypass engine, means it is near turbojet engine operation characteristics. Then this engine will really, this engine's performance will come down, because it is not a jet engine to operate at jet engine speed and that high altitudes. If this is operated, then performance will come down. When you are comparing with high bypass ratio, performance will increase. Like in fuel point of view, fuel consumption will be low for high bypass ratio. So these are the two types of turbofan engine with respect to bypass ratio: low bypass ratio, high bypass ratio. Low bypass ratio is used for military operations. Purpose like here, this is when you are comparing the jet engine to improve the fuel efficiency, this low bypass ratio turbofan engines are preferred, right? So, but when you are comparing with high bypass ratio turbofan engine, which is suitable for lower altitudes and lower speeds, relatively, that is with respect to turbojet engine. So lower speeds means usually, if you see turbojet can be operated up to from Mach 0.7 to 3 Mach, right? Turbofan is suitable from 0.2 to 1.6 Mach maximum, right? 1.6 maximum. So turbofans are suitable for lower speeds and lower altitudes. And that's how when you operate turbofan engine at lower speed and lower altitude, fuel efficiency is very high, fuel consumption is low, and they are quieter. For this purpose, these high bypass ratio turbofan engines are kind of dominating the airline industry. Most of the airlines, for example, like if not aircraft, airlines use this type of aircraft like Boeing 737, 777, 787, Airbus A320. Mostly, these 737 and 320 are used by most of the civil airlines. Not only that, 777, 787 also are there. So these are equipped with turbofan engines, and at Mach around Mach 0.75 to Mach 0.85 in this region. If you operate turbofan engines, they are fuel efficient, right? So that is the reason most of the airlines will run the aircrafts in this speed range only, 0.75 to 0.85. So the majority of the airlines uses turbofan engine, high bypass ratio turbofan engines. So airline industry is dominated by turbofan engines. We can say that anyway. Whereas low bypass turbofan engines are used for military applications. Relatively at lower speeds when you are comparing with turbojet engine, and at lower altitudes when you are comparing turbojet engine. So in that region, low bypass ratio turbofan engines are used. So far we have seen types of turbofan engines by reduction gearbox, with and without, and then single spool and multi-spool, and then this with respect to bypass ratio, that is low bypass ratio, high bypass ratio. And now you can have different type of turbofan engines with respect to exhaust section also. That is turbofan engines can be equipped with different types of nozzle designs. Here, see, you can see, so the air leaving the fan can be ducted overboard by a separate nozzle. This is point 1. And point 2, they can be driven to the end of the exhaust section, end of the gas turbine engine. They can allow to pass through this way also. This is number 2 type. And where flows are separate. And third type is where flows can be mixed. So third type is this ducted turbofan exhaust is mixed with exhaust of turbine engine. So let us see like this. This is core engine. This exhaust is mixed with exhaust of core engine. When both are mixed, this is one type, third type in this case, on whatever the sequence we are discussing. When this fan exhaust is mixed with exhaust of core engine, this reduces the noise. Even 20% thrust exhaust also, 20% exhaust which generates 20% thrust also, if it is mixed with exhaust of ducted fan, the noise can be reduced. And this type of design is used for stealth operations where low noise and low exhaust, low noise is generated. And other type is where the flows are separate. This exhaust flow and this exhaust flow, but the exhaust is pumped, driven up to the end section of the gas turbine. Right? This is second. First one is here itself you have separate nozzle, and it will be allowed to pass through this separately. Right? These are the different types based on different nozzles. Mixed flow, separate flow, and even in separation, at the exhaust, the duct itself separates. The flow is allowed to flow overboard the core engine. Otherwise, that exhaust is allowed to mix with core engine exhaust. Otherwise, at the intersection of a separate flow. Like this, we can have different types of turbofan engines. So far, we have seen 4 different types of not for 8 actually, but by 4 components. That is one by reduction gearbox, another one is spool, another one is bypass ratio, another one is by having different types of exhaust method of exhaust section and different types of nozzle also, right? So like this we can have multiple types of turbofan engine based on the required performance. If it is as we have seen that if it is for stealth operations, this type of turbofan engine where it can have one can have a better fuel efficiency, low noise, third type of exhaust is preferred, right? So like this multiple turbofan engines which rules in the range of Mach 0.75 to 0.85 and they are fuel efficient. We'll see the advantage disadvantages of turbofan engines. When you are comparing turbojet, say turbojets are good for high speed and high thrust, but they consume more fuel. When you are comparing with that, the turbofan engines are fuel efficient and better performance at subsonic speeds. We have seen this. And quieter than turbojet because majority of the thrust is generated by fan, right? So quieter than turbojets and lower operating cost, longer range. Because longer range is because in case of turbojet we have seen shorter range. That is because they consume more fuel. As turbofan engines are fuel efficient, so you can achieve longer range comparing with turbojet. And disadvantages are they are heavier than turbojets because additional component fan and reduction gearbox will be there, are there. So that for that purpose heavier, and not only that because of fan at the entrance of the engine, so large frontal area because of the fan. And this is also one disadvantage which increase not only increase drag but also possibility of chances are more for bird strike, which damages bird strike or any other foreign objects, which damages the fan as well as core engine also. And that's the reason we quite often we hear that bird strike effects. And heavier than turbojet, and they are complex design and maintenance, right? Complex design is like fan and then turbine blades. So operating this multiple rotating components, different stages of turbines, different stages of compressor, multi-spool, then fan, and if required reduction gearbox. All this makes it complex when you're comparing with turbojet, which is simple engine. And inefficient at high altitudes and high speeds. So when comparing with turbojet, actually turbojets are good at high altitude as well as high speed, but turbofan engines are designed are good at lower speeds and low altitude. But when either speed or altitude increases, performance will come down. Reason is due to aerodynamic performance of the fan blades, right? So this is about turbofan engines and comparison with turbojet engine, advantages, disadvantages, working principle, different types and different components. So we can come to conclusion that these are ruling civil aviation industry in the speed range of Mach 0.75 to 0.85 with less noise, better fuel efficiency. Right? And these are the references I used. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.